This is the last part of Chapter 6. Benzene and its derivatives. 6.3 Chemical properties of benzene and its derivatives. The learning outcome for 6.3 Chemical properties of benzene is to explain the electrophilic aromatic substitution reaction of benzene, such as nitration, halogenation, Friedel-Crafts alkylation, and Friedel-Crafts acylation.
The key step of each substitution reaction is attack by an electrophile on the aromatic ring, leading to the replacement of a hydrogen atom in the ring with another atom or group of atoms. Such a reaction is referred to as electrophilic aromatic substitution. The electrophile can be a positively charged ion, E+, or any other particle deficient in electrons. During this lesson, we will study more closely the individual steps of an electrophilic substitution reaction.
Electrophilic aromatic substitution reaction is the most characteristic reaction of benzene. Benzene is an electron-rich species, therefore it reacts with an electrophile, where the hydrogen atom at the ring is replaced by the electrophile, E+. As stated before, why benzene is susceptible to electrophilic attack is due to the benzene ring is actually contain a high electron density. Therefore, the pi electrons are sterically accessible to attack. There are 4 reactions that associated with electrophilic aromatic substitution of benzene, such as nitration, halogenation, Friedel-Crafts alkylation, and, also, Friedel-Crafts acylation. The first one is halogenation. The reactant must contain benzene and halogens, Cl2 or Br2. Iodine and fluorine are exception, because I2 is unreactive, while F2 is too violently. Next, the condition for the reaction to occur must contain Lewis acid, such as iron 3 chloride or iron 3 bromide. For example, when benzene reacts with bromine gas, in presence of iron 3 bromide, the product formed are bromobenzene, where one of the hydrogen is replaced by one bromine, and hydrogen bromide, where the hydrogen from benzene bonded with the leftover bromine atom from bromine gas.
The first step of the reaction involves interaction between chlorine and the catalyst. The chlorine atom is the donor of an electron pair. A complex is formed, with a positive charge on the chlorine atom and a negative charge on the metal atom.
So what is the function of Lewis acid? Lewis acid is needed as to increase the polarity of halogen molecules. It also needed as to produce the electrophile, a positive halogen ions, such as bromine positive, or chlorine positive. You will learn further on this formation, during the mechanism of this reaction. The next reaction of benzene is nitration. The reactant that needed is concentrated nitric acid, under condition of concentrated sulfuric acid, and at between 50 to 55 degrees Celsius. For example, when benzene reacts with concentrated nitric acid, in concentrated sulfuric acid, and at 50 to 55 degrees Celsius, the product formed is nitrobenzene, where one hydrogen from benzene substituted with nitro group from nitric acid, with the water as byproduct. Next reaction is Friedel-Crafts alkylation. The reactant must contain alkyl halide, in presence of Lewis acid as catalyst. This reaction is useful when to add an alkyl group into the benzene ring, to produce an alkyl benzene. For example, benzene reacts with 2-chloro-2-methylpropane, in presence of AlCl3, to produce tert-butyl benzene, with hydrochloric acid as byproduct. The last reaction is Friedel-Crafts acylation. With acyl chloride as reactants, in presence of Lewis acid, where the product is usually contain ketone functional group. Acylation actually means that, to transfer an acyl group to benzene. For example, benzene reacts with acetyl chloride, in presence of AlCl3, the products formed are, acetophenone, and HCl. So these are the summary, for electrophilic aromatic substitution for benzene. Noted that, only one hydrogen atom from the benzene, substituted with an atom or groups for each reactions. You also need to remember, the conditions for each reactions to occur. That's all for 6.3, Chemical Properties of Benzene and its Derivatives. Thank you for watching.